All right, law of sines. So we've gone through solving triangles, right triangles, but now we're going to get into, well, what if it isn't a right triangle? Okay. First, fun fact about ravens and wolves. Wolves are also very cool and fascinating, but they're friends. Like, ravens and wolves aren't friends. Like, the wolf won't try to attack the raven or vice versa. They actually help each other out when they are, like, trying to get their prey or whatever. That blows my mind. Like, that is the coolest. And to think I used to be scared of ravens because I would see them all the time. Like, what does that even mean? Like, this is some existential crisis. Anyways, okay. So, law of sines. They're basically ratios, okay? So, the law of sines is saying, well, okay, if we take the sine of angle A and we put it over the side A, that ratio is going to equal the sine of angle B over side B. And it's also going to equal the sine of angle C over side C. Okay, it's setting up ratios. So these ratios here, let's just take a triangle and let's make sure it works. Okay, so if I do the sine of 59, this one, over its opposite side, so over 19, sine of 24 over its opposite side, which is 9, and sine of 97 over its opposite side of 22. Now, if this is true, these should all be the same ratios, okay? So, if we do sine of 59 over 19, we get 0.045114. If we do sine of 24 over 9, we get 0.045193. And the reason they're a teensy bit off is because these values are rounded. These side values are rounded, okay? And then sine of 97 over 22... I'm convinced, okay? 0.045116. Those are all basically 2, 1, 2, 3, 4. What is that called? If like 4. Shoot. It's a science thing. It'll come back to me. You physics people know exactly what I'm talking about. I forgot it. Okay, it works. Okay. Now, law of sines can be used on the following triangles. So it can be an angle, side triangle, which this is angle. So here's our angle, side, or angle, side. Okay. Or it can be used on an angle, side angle triangle. So that means the side is between the two angles. Or a side angle triangle. Now these side angle triangles, it spells the swear word if you... Whoops. What happened? It spells the swear word if you write it backwards. These ones are kind of a pain in the buttocks. Okay, it's okay. We got it though. So let's use the law of sines here. And let's find missing side measures. Okay, so if we have this triangle right here, well, anytime you're given two angles, always solve for that missing angle, even if you're not going to use it. Okay, so I could do 180 minus 52 minus 34, and I get 94 for that missing angle measure right there. Then I can set up a law of sines. So I have sine of 34 over 10 equals sine of 52 over x. And then I can solve this. It's basically solving a proportion. We can just cross multiply. So that's x times the sine of 34 equals 10 times the sine of 52. Divide by the sine of 34. And we get x equals 10 sine of 32 over sine of 34. I think I said 32. I meant 52. When you put this in your calculator, make sure this parenthesis right here needs to be closed. Okay, that is the most important one. If you don't close it, your answer will be wrong. Okay, also, if your calculator is not in degree mode, it will be wrong. Okay, make sure your calculator is in degree mode. And we get approximately 14.09, which makes sense. Okay, let's do another one. So this one, first let's see what type of triangle this is. I should have done that on the last one. Let's see what type of triangle this is. So we started with this angle, and this side. So that would be an angle, side triangle. Okay. Now this one, we have, again, an angle, and a side. So this is an angle, side triangle. So then we can solve for that missing angle right there. If we just do 180 minus 119 minus 21, get 40. Then we can set up our ratio. So I'm not even going to use the 40 actually. It's just there will be times that you have to use it. So if you get in the habit of just solving for it right off the bat, it's a good habit. So if we do sine of 21 over 7, that equals sine of 119 over x. Cross multiply, we get x times sine of 21 equals 7 times sine of 119. Divide by the sine of 21, and we get 7 sine of 119 over 21, which equals 17.08. And I put this little squiggly equal sign because that means approximately because I rounded it. So that's good practice. Whenever you round, if you just put, well, that's approximately that, it's not. This means that is exactly equal. This means it's approximate, okay? This one. So this one here is an angle, side angle triangle. Okay, so this one we actually do need to solve for that missing angle. So if I do 180 minus 88 minus 65, you get 27. So then we're going to have sine of 27 over 10 equals sine of 88 over x. Cross multiply, x times sine of 27 equals 10 times sine of 88. Divide by the sine of 27, and we get x equals 10 sine of 88 over sine of 27, which is approximately 22. Cool? Easy peasy. They even move. Okay, this one. All right, so side angle triangles is a pain in the, that word. I'm not going to say it. So this one here is a side angle. And notice I did something. I wrote this as a capital S. So here we have a side angle. And I wrote this as a capital S because this side is bigger than this side. Okay, but let's just get into this. So, what are we solving for? Oh, first, okay, we need to figure out, is there a possibility of one triangle, two triangles, or no triangle? So since this side, 23 over here, is bigger than 22, that means if I moved this side around, it's not going to, like, perfectly end at a point, which will be different for when it's less than, okay? It's not going to perfectly end. So that means in this case, there is only one possible triangle. Okay, so when it is the side opposite of the angle is a big angle, there will only be one possible triangle. And we're trying to find, let's find this angle measure right there. Okay, so this is going to be sine of 40 over 23 equals sine of theta over 22, which that's going to be 22. I should maybe go through the steps of this. So we cross multiply it, and we get 22 sine of 40 equals 23 sine of theta. Divide that by 23, and we get 22 sine 40 over 23 equals sine of theta. The other way to think about this problem, which I don't know which one like you guys like more, so I just do it both ways, but sine of 40 over 23 equals sine of theta over 22. Well, this is what we're trying to get alone, right? The sine of theta. So if I just multiply both sides by 22, we get the same thing. 22 sine of 40 over 23 equals sine of theta. I don't care which way you think about it, but. So then we end up with this. Now remember, whenever we're finding an angle, we have to do the inverse. So that means theta equals sine inverse of 22 sine of 40 over 23, which is about 37.94. And I should have put squigglies. I literally just talked about it. But 37.94. Okay, and there's only one possible triangle here, so we can't, we don't need to worry about solving for a different angle. Now let's look at this case. So what about the case where it's side triangle? So now this is smaller than this side, okay? I said something weird, but anyway, so that's smaller. So if we look at that measure right there, well, if I move that, it's going to hit over here somewhere also. Okay, since it's less than, it is going to hit and perfectly make another triangle, which means that we have two possible triangles here. Okay, we have that big triangle, but then we also have this smaller triangle, but they both have that side length of 6. Okay, so here, let's solve first this big triangle for that missing angle right there. So this is going to be sine of 30 over 6 equals sine of theta over 10. So that's going to be 10 sine of 30 over 6 equals sine of theta. So that means theta equals, you do the inverse of both sides. So theta equals sine inverse of 10 sine of 30 over 6. So theta is approximately 50.44. Okay. We also need to solve for this angle right here because there's two possible triangles here, okay? So we need to solve for this angle, and we can just look at this big triangle that we did up here because basically this piece of the triangle is the whole thing. This one is like that little piece right there. Okay. So since these two sides right there in this triangle are the same, I think that's called an isosceles triangle. Hopefully that's right. If not, I apologize, math gods and everyone. Okay. So that means if those sides are the same, the angles are the same. So that means this angle down here is also 50.44. Okay. Now, if that's 50.44 and these are on a line right here, that means they add up to 180. So then I can just do 180 minus 50.44 and I get 129.56. So that other angle measure there is 129.56. Whoops. Okay, so we have two triangles here, and our angle measures would be 50.44 and 129.56. Okay. Let's do another. So we still have this side thing. So measure of angle C is 141. B is 24. And opposite C is 19. Okay, so for this triangle, first of all, if this angle right here is 141, that is definitely the biggest angle, right? Which means the side opposite that angle should be the biggest side. This should be the biggest side. And the reason I know this is the biggest angle is because all the angles add up to 180. If this is 141, that means that this angle and this angle together add up to be 39. Okay, so there's no way that it's bigger. But looking at this, they're saying that, well, this side is bigger. That doesn't make any sense, okay? So from this knowledge alone, just drawing the triangle, I know that there is not even a possible triangle here. Okay, because that is actually shorter. This doesn't even create a triangle. Stop, my dogs came in. Okay, pause. Sorry about that. So embarrassing. Okay, anyways, so that side is shorter. So that tells me that there's no possible triangles here. But let's just pretend. Let's pretend that it is a possible triangle and double check ourselves, okay? Imagination. Okay, so if we have sine of B, we're solving for angle B, over 24 equals sine of 144 over 19. Well, this is going to be sine of B equals 24 sine of 144 over 19. So B equals the sine inverse of 24 sine of 141 over 19, which is 52.6. Okay, so they're saying that angle right there is 52.6. But, hold up. If I do 180 minus 141 minus 52.6, I get negative 13.6. So that means that this angle right here is negative 13.6. That makes no sense, right? No sense making. No, none. Okay, so that means that this is not a triangle. Okay, let's do one more case. So this one, angle A is 93. C is 18 and A is 15. Again, this is the biggest side. This is the biggest angle. This should be the biggest side, but it's not. This is the biggest side, which tells me there is no triangle possible here. Okay, but double check ourselves. Let's just pretend. Don't. Let's do the math and make sure. Okay, so for this one, we need to find angle C before we can find angle B. So if we do sine of C over 18 equals sine of 93 over 15, I get 18 sine of 93 over 15. So sine C equals sine inverse of 18 sine of 93 over 15. Which if you put that in your calculator's like, no, you cannot do that. You get an error. Okay, so if you get an error, that means it's not a triangle. All right, we'll go over more in class, but that's it. Bye, guys.